This is Quick Clip 4.03, calculating speed. And for our first example, we have a little dog running 75 meters to the finish line. And the stopwatch up on the left will tell us the dog's time after the race. So the dog goes, runs, crosses the finish line, and we have a total of 5 seconds. So your task is to calculate the speed of the small dog using the formula for speed, which is speed equals d over t, or distance divided by time. And so the distance was 75 meters, and that's over 5 seconds. So 75 divided by 5 comes to 15 meters per second, and that's the speed of the dog. Next, we have a runner running a 100-meter dash. Ready, get, set, go, and the runner is finally crossing that finish line, taking a total of 13 seconds. And again, calculate the speed of the runner using the formula speed equals distance divided by time. So the 100 meters goes on top, 13 seconds goes on the bottom. We divide that and we come to 7.69 meters per second. All right, another thing that you'll probably be asked to do in the unit is to calculate the speed of an object by analyzing a line graph. And so we have two examples here, car 1 in the green, and we'll first take a look at that end point of that car, and we can see that its distance was a total of 50 kilometers. And then moving straight down to the x-axis from that end point, you can see that the time it took was about 2.5 hours. And so plugging that into the formula, we have 50 kilometers over 2.5 hours, and so our speed becomes a very slow 20 kilometers per hour. Next, we'll look at the red line for car 2. And again, we look at the endpoint, and we move across to the y-axis, and we see that that is level to the 50-kilometer mark. We move down to the x-axis, and we see that it's equal to the 5-hour mark. So we have 50 kilometers divided by 5 hours, again distance divided by time, and we end up with an even slower 10 kilometers per hour. All right, now finally I wanted to point something out to you, adding this third car in the purple there. What would your prediction be for the third car? Will it be faster or slower than the other cars? And you may well say that it is slower. You'd be absolutely right. And we could do that without even calculating any of the math. We can just take a look at the slopes of the line. So taking a look at the green line, you can see that it is a much steeper slope. And when you're looking at graphs like this, the steeper the slope, the faster the object has been moving. Think of it as a side of a hill. And so the hill that has the green slope will reach 50 kilometers much faster than the slope with the red hill, or the hill with the red slope. And so if two dogs were running up the hill, then the dog on the green slope would reach 50 kilometers faster than the dog on the red slope. So the steeper the slope, the faster the object on these graphs. We can calculate car 3 regardless. So we can see that car 3 is at 35 kilometers and took 5 hours to complete. And so its speed would be 7 kilometers per hour, and it is indeed the slowest of the three cars.